A-level, Pure 1, Sequences. The sum of an arithmetic progression. Let's see how we can find the sum of the terms of an arithmetic progression. If we add together the terms in a sequence, we call the result a series. For example, we may want to add together all the odd numbers between 1 and 100. Now to solve this, the numbers are 1, 3, 5, 7, 9, 11, and so on up to 99, and there are 50 numbers in this sequence. If we write down the series once in increasing order, and below in decreasing order, and then add vertically, we have s plus s is 2s, and that's equal to 1 plus 99, which is 100, plus 3 plus 97, which is 100, plus 5 plus 95, which is 100, and so on, up to 99 plus 1, which is 100. Now there are 50 terms, so we have 2s is equal to 50 times 100, which is 5,000. So s is equal to 5,000 divided by 2, which is 2,500. So the sum of the odd numbers between 1 and 100 is 2,500. We can use this same method to find a general formula for the sum of a series. Suppose we have a series a plus d plus a plus 2d plus a plus 3d and so on with n terms. Let the last term be L. Then we have the sum of all the terms is a plus d plus a plus 2d and so on till we get to L minus d plus L. Now we can write that formula in reverse. So s is equal to L plus L minus d plus L minus 2d and so on till we get to a plus d plus a. Now if we add vertically, we have s plus s is 2s, and then that's equal to a plus L plus a plus d plus L minus d, which is a plus L, plus a plus 2d plus L minus 2d, which is a plus L, and so on until we get L minus d plus a plus d, which is a plus L, and finally L plus a, which is a plus L. So we have n terms, each of which is a plus L. So 2s is equal to n into a plus L, or Sn is equal to n over 2 into a plus L. Now that's a very important formula which we must know. But the last term, L, is the nth term. So L is equal to a plus n minus 1d. So Sn could be written as n over 2 into a plus n minus 1d. Or Sn equals n over 2 into 2a plus n minus 1 times d. Now we've got two very important formulae here which we must know. The sum of n terms of an arithmetic progression is given by Sn is equal to n over 2 into a plus L, or Sn is equal to n over 2 into 2a plus n minus 1d. Now we can use these formulae to solve various problems. For example, find the sum of the first 40 terms in the series 7 plus 8.5 plus 10 plus 11.5 plus 13 and so on. Well, to solve this, we have a is equal to 7, we have d is equal to the difference between the first two terms, so that's 8.5 take away 7, which is 1.5, and the total number of terms n is 40. So S40 is equal to 40 over 2 into 2 times 7 plus 40 minus 1 times 1.5, which is equal to 20 times 14 plus 39 times 1.5, or 20 times 14 plus 58.5, which is 20 times 72.5. So S40 is equal to 1,450. In other words, the sum of the first 40 terms is 1,450. Let's look at a second example. How many terms of the series 3 plus 7 plus 11 plus 13 and so on are needed to make a sum greater than 10,000? To solve this, we have a is equal to 3, d is the difference between the first two terms, so that's 7 minus 3, which is equal to 4, and the sum of the terms is greater than 10,000. Now we can use our formula. The sum of n terms is equal to n over 2 into 2a plus n minus 1d, and that is greater than 10,000. So if we double both sides, that gives us n into 2a plus nd minus d is greater than 20,000. And we know a is 3 and d is 4, so n into 6 plus 4n minus 4 is greater than 20,000, or n into 4n plus 2 is greater than 20,000, or 4n squared plus 2n minus 20,000 is greater than 0. Now to solve an inequality, it's easier to treat it as an equation, so if we divide by 2, we can get the equation 2n squared plus n minus 10,000 equals 0. Now the easiest way to solve this is if we have a calculator capable of solving quadratic equations. But if not, we can use the quadratic formula. N equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we substitute in a is equal to 2, b is equal to 1, and c is equal to minus 10,000. Now that gives us a fairly complicated expression, but it simplifies down to n is equal to minus 1 plus or minus the square root of 80,001 over 4, which simplifies to minus 1 plus or minus 282.84 all over 4. So n is equal to 40.46 or minus 70.96. Well, n has to be positive and a whole number, so we want the next number greater than 70.46, and so we would need 71 terms. Now let's have a look at one more example. The sum of the first 5 terms in an arithmetic progression is 70. The sum of the next 3 terms is 78. Find the first term and the common difference. Well, to solve this, we have the sum of the first 5 terms, S5, is equal to 70. Now we have the formula Sn is equal to n over 2 into 2a plus n minus 1d. And we can substitute in n is 5. That gives us 5 over 2 into 2a plus 5 minus 1d is equal to 70. If we double both sides, that gives us 5 into 2a plus 4d is equal to 140, or if we divide by 5, 2a plus 4d equals 28. We'll call that equation 1. Now we also have the sum of the first 8 terms is the sum of the first 5 terms plus the next 3 terms, so that's 70 plus 78, which is 148. So 8 over 2 into 2a plus 8 minus 1d is equal to 148, or 4 into 2a plus 7d is equal to 148, and if we divide by 4, 2a plus 7d is equal to 37. We'll call that equation 2. Now, if we have equation 2 take away equation 1, that gives us 2a plus 7d equals 37, and 2a plus 4d equals 28, and when we subtract, that gives us 3d equals 9, or d equals 3. So if we substitute that in equation 1, that gives us 2a plus 12 is equal to 28. In other words, 2a is 16, or a is 8. So that gives us a first term of 8 and a common difference of 3. Now we can check this one fairly easily. The series is 8 plus 11 plus 14 plus 17 plus 20, and the first 5 terms do add up to 70. Now the next 3 terms are 23 plus 26 plus 29, and they do add up to 78. So we have checked our answer.